Hi everyone, today my classmate Luis Vázquez and I, Irene Mena, we are going to talk about 4 of the most used microscopes in nanotechnology, their applications in this field, and some articles of interest. The first microscope we'll see will be the scanning electron microscope. Scanning electron microscopy is based on the emission of a scanning electron beam over the sample, where the electrons interact with the sample producing different types of signals that are picked up by detectors. Finally, the information obtained in the detectors is transformed to give rise to a high-definition image with a resolution of 0.4 to 20 nanometers. That is, we obtain a high-resolution image of the topography of the sample surface. Thanks to this type of microscopy, we are able to obtain superficial information of the shape and topography of the sample, its texture and composition.
Application. We decide to know some of the application of the type of microscope based on the article card insists of the formation mechanism of nanostructure titanium oxide polymer from different macromolecular metal complex precursors with the use that they decide to use CM because this type of microscope confirms the existence of nucleation of metal oxide nanoparticles in the form of bars. If we observe the images on the screen with decationation temperature increase, microfibers composed of agglomerated nanoparticles of 20 or 30 nanometers are created. Likewise, the morphology of calcinate produced under different conditions is shown.
The transmission electron microscope is a microscope that allows the study of the structure of matter. In this technique, the electron beam has an acceleration voltage high enough to go through ultra-thin sheets, approximately 100 nanometers. Thus makes image that, when interpreted, can provide information on both the microstructure and the structure at the atomic and molecular levels. These microscopes have a resolution capacity of up to 0.23 nanometers. It has very important applications in the biological, metallic, mineral, and ceramic areas. Some examples of these are the characterization of nanostructures and the study of nanostructured materials such as nanoparticles, nanotubes, graphene, catalysis, and others.
Applications. On this time we take as a base the article nanoscale structure characterization of magnetic fields integrate to silicon correlate with their magnetic and electric properties, in which we can observe in these images a heterostructure of various compounds. Likewise, it is possible to appreciate interface and layers of 75, 30, and 20 nanometers respectively.
The scanning tunneling microscope is based, as its name indicates, on the tunnel effect concept, when a conductive tip is placed very close to the surface to be examined. A bias current applied between them allows electrons to pass from one side to the other thanks to the vacuum. This microscope is used to obtain image of matter at the nanometer scale. It also allows individual atoms to be manipulated, making it essential in the characterization of materials, in the development of nanotechnology, and in the understanding of phenomena related to the infinitely small. It should be noted that it has resolution of 0.1 nanometers. Atomic force microscopy is based on mechanical detection of the surface with a very fine tip and is used for imaging and spectroscopic analysis of a variety of surface properties and nanometer resolution. This type of microscopy can achieve sub-nanometer resolution while making it an instrument capable of allowing the quantitative study of the three-dimensional structure of the surface and its magnetic, mechanical, electronic, and chemical properties.
Applications. STM and AFM microscope can usually be employed in almost the same areas, so it's common to find them in combination in different papers below well specifically talk about the article. A combined optical and morphological study of 2.5 bits to the connected phenylene butadiene fields for OLEDs, in which we found that the morphological properties we investigate and the atomic level by STM and the macroscopic level by FFM to obtain information on the molecular organization in the sample and their relationship with the type of spectroscopic aggregates.
That's all from our side, and we hope you like it. Have a nice day.